Thanks, mate. Can you chuck them up there for me? Cheers. Just on the windowsill here behind me. All right, let's talk about horizontal projection. We're very quickly getting into launching balls from catapults, so get excited. Now, to be clear, this is horizontal projection. That's horizontal projection. Horo project, proj, right? This is not. Ooh. This is not horizontal projection, okay? This is horizontal projection. This is not. This is projection at an angle. We will do that next lesson, okay? They are different. Not significantly, but the formulas we use and the logic we use is different. For a key reason, horizontal projection is not symmetrical. Projection at an angle is symmetrical from the point we are at, the peak of our drop. And we've spoken before about the velocity of an object in the vertical direction at the peak of its drop. What is it? When I do this, when that was at the peak of its curve, what was its vertical velocity? 0. As soon as it hits that peak, stops. If we froze, if we took a photo, it would not be moving up or down for that moment, right? And then it accelerates downwards, okay? And this is all dependent upon gravity. And a lot of these situations that we're going to analyze are gravity situations, okay? So we're not going to look at projection at an angle yet. That's a whole different kettle of fish. We'll do that next time. We're just going to look at horizontal projection, okay? There's also several different cases that can happen. Now, a quick comment on notation here. We're now getting into stuff that comes from your formula and data book. So we want to use the correct notation to match with your formula and data book, okay? So subscript X for horizontal, obviously, right? That should be no big shock. Subscript Y for vertical. Whether you even feel like you need to write this down, I'll let you decide. Subscript Y, and remember what I mean by subscript? Yes, you all know what I mean by subscript. X, this is my subscript, X. That's the subscript, little letter down the bottom, okay? Subscript Y for vertical. And then the following, U equals initial velocity. So if it's UX, what is it? If it has a little x there, it's initial velocity in the horizontal. If it has a little y there, it's initial velocity in the vertical. Okay. V, final velocity. Okay. A, acceleration, obviously. And again, all of these things can be dictated to be either horizontal or vertical. And we do not want to deal with situations where we have resultant vectors. We always want to break them into or resolve them into their components. So if you're given an acceleration on an angle, right, you can break it into its resultant vectors. And you can imagine the acceleration affecting it horizontally and vertically, totally separately. Okay. G equals A due to gravity, right? That'll come up a lot. You ready for that one? Oh, S. Don't forget, S equals displacement. And that should be about it, okay? So if I'm talking about SX, I'm talking about how far something traveled in the X direction. Yes? Okay. Let's get into an example. everyone okay if I go to the next page, or does someone still need that? We're okay? Speak now, forever hold your peace. Kobe's got Campbell, the Brains Trust. I feel like Kobe and Campbell would be a good name for a TV show, actually. Kobe and Campbell. Yeah, oh yeah, absolutely.
It sounds like a good podcast.
Yeah, true, yeah. Just talk crap for 40 minutes, like most podcasts. Good work. All right. Please, yeah, this is all on record, by the way. If you ever get famous off it, it was my idea, and I would like to take a 20% cut. A golf ball is projected horizontally off a cliff at 20 meters per second. Horizontal projection. You should identify that, and you should dictate that in a diagram that you draw very clearly. Diagram. Every time. Number of diagrams you're going to draw in physics, you're going to become an artist by the end of things. Golf ball, projected horizontally off a cliff. Now, why is it important that we recognize that this is horizontal projection? What is it about this that is important about this? It says it's projected horizontally. So what am I going to write as my known information right here on that vector that I've just drawn? Jelly bean to whoever gets it right, except I don't have any. I'm still waiting. The x is wrong. What's the notation? Subscript x, yes. What does v communicate? Final velocity. ux. I don't have any. I'm a liar. What are you going to do? Sue me? I'm a public servant. You won't get money out of me. Anyway. What's that? I didn't introduce that notation, but I'm sure we're familiar with it. T. Writing down unknown information to reach the ground. Here. Right. Calculate how far out from the base. How far out from the base? What's that? Jelly bean to whoever can tell me. Correct notation. Tell me the notation. SX. Max, you're getting nothing.
Metaphorical.
A high five. I'll give you a high five. Yeah, true. You have it recorded. All right. Now, hang on a second. That can't be enough information to solve this problem. Of course it is. Because we're not going to accelerate in horizontal directions. Ever. You guys are not assessed on understanding problems with air resistance. Exactly. Who cares? It is in your syllabus to understand the effects of air resistance, but you are not actually required within your syllabus to calculate, including air resistance, for this sort of topic. Okay? There will be force calculations that you'll do where you have to take into the role friction and air resistance and stuff like that, but that's different. So, after 4 seconds, if you were traveling at 20 meters per second, you continue traveling at 20 meters per second for 4 seconds. Your formula here is Sx equals uxt. And that is in your formula and data book, which I had. Oh, I threw it. That's right. Where is it? There. Gravity in motion. Sx equals uxt. Now, pay attention, yeah? Don't go here thinking this is all of your motion formulas. There's a whole nother set of motion formulas down here. Please don't go to this and be like, oh, I can't find the formula I need. I give up. There's 2 separate sections of motion formulas. Okay? Let's finish this example and then we'll pack up. Sx equals ut. Sx equals 20 times 4 equals 80. 0.0 meters per second. Wait, what? Meters. meters per second, seconds. So the seconds cancel. That's meters. Okay. That's the easy one, just finding how far we travel horizontally. But you could also be asked what the vertical final velocity would be. What the final velocity would be on an angle. And you can be asked all of that because you know what? Acceleration in the y direction equals g. You also know what about the initial velocity in the y direction? 0. There is no initial velocity in the y direction. These are really important things to identify when you are told that you are getting projected horizontally. Okay? When we do horizontal projection, you know there is no initial component of vertical velocity. You know that it's a gravity-style problem, assuming it's some object in the universe moving through the universe, ideally on Earth. But I could ask you a question about the moon. Hey? Good question. Good question. We'll leave it there. I'll let you guys make sure your notes are nice and neat and pack up. Again, feel free to start that Chapter 1 review this week. But on Monday, we will come back to this and finish this off with a bit more horizontal projection and then projection at an angle.